And with all the previous presentations, we really focused on secondary education, and with the next presentation we're going to make the next step, because we're also going to look at how the predicting power actually of mathematical tests of INVALSI on a STEM career at university, and also looking at possible gender differences there. So we're going to move from secondary school to more equality maybe in higher education institutions. And this is going to be presented by Patrizia.
Hello, good morning everyone. I'm Patrizia Gianantoni from INVALSI, and this research is a joint project together with a colleague and responsible of the statistical office of INVALSI, Patrizia Falsetti. And we have been working on this project for at least 3 years, and the focus is on the imbalance in the selection of university courses, the gender imbalance, particularly looking at those courses with a high scientific and technology core, the so-called STEM courses. As you all for sure know, this is not just an Italian problem, this is a global issue, but even among Europe or the international situation, Italy, there are some differences, and Italy is not performing very well, it's quite low. This is the proportion of employed women in STEM. The picture is quite the same if we look at university. As you probably imagine or know, what we observe at university is not an isolated phenomenon, but it has roots long before, and it can be represented in a simple way like this. It started already in primary school, when we start to observe gender gaps very early. Gender gap in mathematics. We all know that it's not linked to biological or neurological differences, but mainly because of stereotypes, as Marta introduced before. And so that was the starting point, but then in turn it's like this chain of disadvantage, because when it comes to high school, we find that less girls with respect to boys select a scientific track, for example, scientific lyceums, so the proportions are lower, and then eventually with the university we found very lower enrollment rate in STEM courses. But what is to bear in mind here is that this disadvantage is not just something that we observe at the beginning, and it's a reproduction of the same disadvantage step by step, but each step is like some added quota of disadvantages is added, so the gap is becoming wider, going from one level to the other of the chain, and we will see an example of this in a few minutes. So in this, say, cultural social issue, it's placed our work, which is in the context of this research project. This is a national research interest project, which is together with, we are very, very pleased and happy to be part of it, because it was huge and has a very well grounded database from analysis. It is headed from the University of Palermo in Sicily, and then also the Ministry of Education, INVALSI, University Register, and many other universities are involved. And the idea was to create this longitudinal set of data that covers the student from the beginning of primary school with INVALSI data until the end of school, grade 13 of schooling with INVALSI data, but then the jump is to link this data with university, having information about university enrollment, and later on university career, until eventually the final degree at the university. So we really look at these students for their entire school career, and it is done at population level, so it's really a huge amount of data. So what I want to stress a bit here about this is that a big effort, a big part of the work was not only the analysis, but also all the work to build this kind of match data. yesterday, after the Al-Intenisi speech, there was arises this issue about how important it is to have matched data, how difficult it is because of privacy barrier, guarantee of privacy. So we moved into this regulation and really try to work to build this data set, which is quite, in education, at least in Italy, is one of the first examples of this kind of matched population data. This is a schematization of the entities involved with their data. So basically, INVALSI, Ministry of Education and University are linked together, and the Ministry of Education was the bridge among institutions, because as there was a double coding of students and they have both the information, so they mixed together all the information, and then everything was obviously re-anonymized and then distributed to the partners or the entities to have the same shared data sets. What we have added now is this last part. We received this data just two months ago. They are quite brand new, and they are about the university career. Until last year, we only have the first step, the university enrollment. So this is the new part. But we work on that just a few months for the really preliminary results. These are some of the variables we got from the institutions involved. So from INVALSI we got information about the students, like migration background, the regularity in the studies, socioeconomic status, and then of course score at INVALSI, mathematical tests, and also the teacher's evaluation of the students. From Ministry of Education we have the key variable was the year of diploma, because we have to link the students that finish their course of study with INVALSI scores and then with university. But we also have some anographic information, and we use them for cross-validating INVALSI data about the students to see their reliability of our anographic data about the students. And then the last part is that of university data, and here we have the year of enrollment, the course, the class of discipline that the student has selected, so we can dichotomize them in STEM and not STEM based on official classification. And this last part is this number of exams. Actually, it is credits that students got each year for the 3 years from 2019 to 2022. As you regularly attended the seminar, the INVALSI seminar, there was previous episodes of this work since we have been working for a while. So brief recap just to continue exactly from where we left. What we showed at the very beginning is this unbalanced rate of enrollment at university between boys and girls. As you can see, STEM is absolutely in favor of boys, and on the opposite, some disciplines like humanities, arts, teaching, especially, they are quite filled for girls. Apparently, it's quite strong. You may say, okay, but that's because it reflects the fact that already before girls have selected scientific lyceum less, technical school less, so obviously later on they are less prone to go to STEM university course. But that's true, that's not all the story, because the whole story, because even if we look only at scientific students, these are the proportion of enrollment in STEM courses at university, so even if we start from the same starting point, girls are selecting STEM courses at university less, 42% against 54, so it's about 20% relative difference. Having the same base and having, like, we can hypothesize that you have selected a scientific lyceum, you are willing to proceed in a scientific career, so why shouldn't go in that direction? That was last year, one extra from last year results. We started to look at the relationship between selection of a STEM course at university and your performance, your ability in math. So that was predicted probability of selecting a STEM course given your level at INVALSI test on the x-axis. So of course, the better you are in math and the more you are going to select a STEM discipline at university, and it's translated up by mother's education. But we didn't have time to check this kind of relationship in a more structural model, which is what I'm show you now. So as I said before, we also have this green part. The blue part was the basic structure of the sample. We now have also this green part here, so the information about the university career of the students. And we try to work on two directions. The first one is to study the impact of ability, math, and also other variables on the probability to enroll to select STEM courses at university. We work only on students from scientific lyceum to have. Is that a question?
Yeah, can you just clarify what universities are we talking about? Are they all Italian universities?
Yeah, all the Italian universities.
So like matched, all Italian universities matched with the INVALSI data?
Yeah.
Okay.
Yeah. Yeah, there are only students from scientific lyceums to have an homogeneous basis, since we have the numbers to look at this data. And then here we have a dichotomous variable, so yes or not the selection of STEM, which is, so we perform a logistic regression. The second part was to study, again, the impact of ability in math, but in this progression in STEM courses, how good you are in going ahead in the university. We just started this part of work, but here the outcome variable, the sample is the same with the fact that only students in STEM faculties are included, and then the outcome variable is the number of credits that the students have by each year in university. So let's go to the first part of results. The questions were, who are the scientific students that go on in a STEM career? What is most important in give you the idea to go ahead? And is there a different pattern of predictors for girls and for boys? So there is a gender effects on what influence your propensity to select a STEM course at university. So we stratify the sample. There are always only students for scientific lyceum, so we stratify by gender. Since we have the number, we still, even if we select in a subsample, we still have high numbers to perform the analysis. And these are the variables we put in the model. So we have the geographical area where the school of the student was located in INVALSI test, the migration background, if the school was public or private, and the regularity in the course of study. Then we use two socioeconomic variables, the index ESCS and moderate educational attainment, and we also selected two variables to capture math skills, the teacher marks and the INVALSI score tests. Obviously we have to select just one variable for socioeconomic aspects and the other for the skills because of multicollinearity, so we checked which was working fit better the model, and we selected moderate educational attainment for socioeconomic, and for the skills we found out that the teacher scores fitted better the data than INVALSI test in this kind of model, so these two were selected. I show you briefly the results. This is the model for girls. In green you have positive effects on selecting a STEM course at university, and in red a negative effect. So you can see that, well, obviously having good and excellent evaluation from teachers in maths has a strong effect. It's excellent, more than doubles your probability to select STEM, but also having your family educational level, which moderate educational attainment is a proxy, and then there is a small geographical gradient in negative going to the south that we know. In the model for boys, we found a similar result about teacher marks. The effect is even stronger because it's 3 times higher your probability to select STEM if you have an excellent evaluation. But what we found more interesting, to go more deep in it, is this apparently, not apparent, but negative effect of having higher social cultural level of the family, which we interpret, of course, there could be more interpretation, but we interpret it in this way. Gender stereotypes are working also for males. So probably here there's the opposite effect of what we observe for females. That males are in a way addressed to select more a scientific career because you are more successful, you will earn more, so they are expected more to go in that direction with respect to others. So probably here, if your family level, educational level is higher, you're more free to select what you really want. So here it could be that this is a quota of boys that prefer to do teaching instead of engineer, and they are more free to do so instead of be forced in another direction. So gender stereotypes can really have negative impacts on both directions, also for boys. Last part is this just preliminary study of determinants of career. This is briefly just technical aspects in the construction of the sample, because we have many observations for the career, and then we reconstruct this wide sample with all the information about the credits that the student has for the 3 different years. And so these are the variables. We selected only students that immediately after the end of school, the 13th grade, they enroll at university. There are also students that just stop for 1 year, they take a kind of sabbatic year and then they start, but we need to have a sample homogeneous that proceeded at the same pace. So they are all those who enroll next year, and then we use as the outcome variable this number of credits, formative credits, which is basically the number of exams weighted by the difficulty the study required. The first thing that we observed is that obviously they are not the same students over the year. There is like a fall of students, and we borrowed the idea from survival analysis. We want to plot this kind of survival curve, so students that are remaining in STEM or leaving the course. And there is a drop in the first year, which for sure is in part due to the fact that if you have selected a way and it's not good for you, you understand already in the first year that something is not going the direction you predicted, so you left. But it's also probably the year 2020, so it's probably also due to COVID. We have to reproduce the same analysis with post-pandemic scores. If we look at the same graph divided by gender, you can see that both boys and girls go down, but the fall is sharper for boys. You don't see clearly here, but you can see more clear here, because this is the proportion that we found going over the years. So for girls, after 3 years, we found 91% of girls still there. They're surviving more in STEM, whereas boys are only 88%. So they are less at the beginning, but then they remain more. Is that because they are more selective at the beginning, or just because they are more willing to arrive? We have to go more deep into that. I want to show you just the last 2 results, and this is still just descriptive results, but about the number of credits that boys and girls get each year. And here you see these are, credits go from 0 to 60, 60 is the maximum per year. So each year, and these results are not cumulative, so each year is from 0 to 60. And girls are are outperforming boys each year, and we then refine a bit the analysis, only looking at the so-called top performers. So students who got a very high level at INVALSI test in the last year of schooling, grade 13. These are the top performers, and they are still reproducing the same kind of results as girls are a bit higher. This is anyway a significant difference for all the 3 years. So future development, there is still a lot to do. We would like to perform the same basic analysis also on different cohorts. It would be interesting to use also marks in the exams, which we don't have now, but we expect to have even more pronounced differences, because girls on average have also higher marks. And then we, of course, we'd like to perform a regression also on the career number of credits to see if the determinants are similar or different from those of enrollment. And then also general, more complex model can be performed, but we are still at the beginning, so any suggestion, comment would be absolutely welcome. Thank you very much.